Have you ever found yourself needing to filter through a large collection of data, only to realize that copying everything would be a waste of time and memory? If that sounds familiar, you're in the right place. Today, we're diving into how to create iterators for a filtered vector in C++. I totally get it. Working with large datasets can be a hassle, especially when you want to avoid unnecessary copies that slow down your program. You're not alone in this struggle. Many developers face similar challenges when optimizing their code. Here's the specific question we're tackling today. One user asked how to create iterators for a filtered vector of spot deal objects without making copies. They want to pass these iterators to a function for computation. Sound like something you've encountered? Let's explore this together. So, what's the issue here? The user has a vector of spot deal objects and wants to filter it based on certain criteria, like currency pairs. Instead of copying the data, they want to create iterators that point to the filtered results. This is a smart approach to save both memory and processing time. And stick around. At the end of this video, I'll share a handy tip that will make your iterator creation even more efficient. To create filtered iterators for the vector of spot deal, the user should first define the helper function called makeFilteredIterator. This function will take a vector and a filtering condition as parameters. Next, the user needs to implement the filtering logic using lambda functions. These lambda functions will specify the conditions for filtering the spot deal objects based on the CCY pair attribute. Now, the user can create the iterators by calling the makeFilteredIterator function with the spot deals vector and the respective lambda functions. Finally, the user can pass these iterators to the foo function for further computation. This allows for efficient processing without unnecessary copies of the data. Fun fact, did you know that the concept of iterators was inspired by the way we browse through books? Just like flipping through pages, iterators allow us to navigate through data seamlessly. Now, let's look at the answers provided by other users. This user provides an alternative solution using a custom filtered iterator in C++. They define a structure called filtered iterator that takes a base iterator and a filter function. This allows you to create iterators that only return elements matching your criteria. The user also mentions that you can specify an end iterator, which is useful for filtering a subset of the container. This flexibility allows for efficient iteration without unnecessary copies. Let's check out another perspective from a different user. An alternative approach suggests using the standard algorithm std stable partition to separate your vector into two ranges based on a filter. This method avoids the need for creating custom iterators. With this method, the begin and end iterators remain valid, and you can loop through the two ranges easily. The first loop processes elements where the filter returns true, and the second loop processes the rest. Now, let's see a response from a different user. An alternative approach suggested by a user is to explore Eric Nibbler's Range v3 library, which aligns with the C++20 standard. This library allows for efficient filtering of vectors using a more modern syntax. That's all on that answer. Let's take a look at another one. This user suggests an alternative approach using C++20 ranges instead of iterators. They recommend using the filter range adapter from the ranges library to create views over the original vector without making copies. The user explains that this method avoids temporary vectors and allows for customized iteration. They also mention that the function foo can be declared as a template to handle the complex types of the ranges. Let's take a moment to review another user's answer. An alternative approach to creating filtered iterators comes from a user who has tackled this problem. They suggest implementing a filter class that encapsulates the filtering logic. This class includes a custom iterator that skips over elements not meeting the filter criteria. The user highlights some pitfalls to be aware of, such as ensuring the first element is valid and handling the end iterator correctly. They emphasize that filtering can be complex, but their solution provides a structured way to achieve the desired functionality. Here's that handy tip I promised. Always ensure your Lambda functions are efficient. A well-optimized Lambda can significantly speed up your filtering process and improve overall performance. And there you have it. You now know how to create iterators for a filtered vector without unnecessary copies. Remember, optimizing your code can save you time and resources. If you found this video helpful, please subscribe for more programming tips and tricks.